Just like with many of the other things we've done in this part of the unit, you might find this written slightly different in a different place. There are multiple different ways to write this same type of equation. This is the equation that we have seen, and it's the one that we use. It's the most useful. But you could see this written slightly different if you're looking at this on another resource. So here's the equation. We use T over F plus T over S equals 1. Um, and the reason why we do this is they are completing one job. So if we think about the example we're talking about right now, they're going to clean one garage. So they're completing one full job. T over F is what percent of the job is the first person doing, and this is what percent of the job is the second person doing. So we're really saying, I might do 3/4 of the job, and you might do 1/4 of the job, and that completes one whole job. So you can kind of think about that when you're trying to set up your equations. These variables are given over here. So T is that time together. And because the time together should always be less than any individual, it goes on top. The smaller part goes on top. And then F is just the time of the first person, S is the time of the second person. You can change F and S around to be different variables if you want to go ahead and label them. It does not matter who is your first person and who is your second person. So we go ahead and finish this. I would actually say my variables are going to be T, F, and A, because I have together Franny and Angie. So you can change those variables as long as you're doing the same idea. So as I go through it, I see that Fran can clean the garage in 3 hours, so F would be 3. But it takes Angie 4 hours, so A would be 4. How long does it take them to clean the garage if they work together? So that would be what I'm trying to solve for. I'm going to use that equation. The T we said always goes on top. That together time always goes on top. The first person, which we said was Franny, goes right here. The second person goes over here, and it's always set equal to 1. So once again, it did not matter who was first and who was second. I could have put the 4 here and the 3 here. As long as the individual times are going in the bottoms and you have the together time on the top, that's all that matters. At this point, I'm ready to solve, and you can see it's a rational equation. We know that in order to solve this, we want to make sure that we have a common denominator. So when we try to get this side down to 1, we need a common denominator. So I multiplied them as a well-chosen 1 to the other fraction because the denominators did not have anything in common to start. Now that they have a common denominator, I can add. So 4t plus 3t is 7t. So now we're down to 1 fraction, 1 fraction. We know then in order to solve this, we cross multiply. That gives me 7t equals 12. Now I'm ready to solve, so I can divide both sides by 7. And we get t equals 1.71 hours. In my mind, that makes sense because if they're splitting the job, they should both be doing about 50% of the work. However, Fran can work a little bit faster than Angie. And so half of Angie's time would be 1.5, but she can work a little bit faster than Angie. We got to correlate to the fact that Angie's half would have been 2. So this number is between 1.5 and 2. It's between their halves. So that's kind of a cool way of thinking about it. And so it would take them 1.71 hours to do it together. This is obviously assuming that their rate would not be affected by each other. We've all cleaned with a family member and finds out that sometimes it could be a longer ordeal. So this is obviously making the assumption that they would keep their same pace working together as they would working individually. Let's see if we can do another example. After a heavy snowfall, Brian can shovel all of the driveway in 30 minutes. His younger brother, Alan, helps. If his younger brother, Alan, helps, the job takes only 20 minutes. How long would it take Alan to do the job by himself? So the first thing we want to do again is define those variables. So I'm going to have together, I'm going to have Brian, I'm going to have Alan. Well, it says, how long would it take Alan to do the job by himself? So A is what I'm trying to solve for. Brian can do it by himself in 30 minutes. And it says if his younger brother Alan helps, so that means if Brian is doing it and Alan's helping, so they're doing it together, it only takes 20 minutes. So now we can come over here and do our fraction. our equation, we know it's equal to 1. Whatever our t is goes on the tops, so it's going to be 20 this time around. First person goes on the bottom, second person goes on the bottom. So my first person is going to be 30. My bottom person is going to be A. That's actually what I'm trying to solve for, is Alan. Now at this point, there are actually multiple different ways that you could solve this. You could go ahead and make this side have a common denominator and go ahead and add and then solve it like you could. Some people have noticed that because this is just a number and this is just a number, we could actually move this to the other side. I'm going to do the method of combining the side because I have been doing that. But if you wanted to bring the 2/3, because 20 over 30 does reduce down to 2/3 to this side, you could. I'm going to leave it as is and solve it from here so you can see we can always use the same method. So once again, in order to add, they need a common denominator. So 30 and A don't have anything in common, so we're going to multiply them by each other. And that gives me 20A over 30A plus 600 over 30A equals 1. They have the same denominator, so I can go ahead and combine like terms. And now we're ready to cross multiply. Now we're ready to solve. So solve, I want to isolate the A, so I'm going to put it on the same side. I can divide both sides by 10. We find out A is 60, so in context, that means Alan needs an hour to shovel the driveway. All right, I have one more of these examples for you. This next one is slightly tricky. Put some information together. You have to be we have to do some mind solving here. So, Marco can build a laptop twice as fast as Cliff. Working together, it takes them 5 hours. How long would it have taken Marco if he were working alone? So just like we've done, I'm going to do my variables. I know that I'm going to have the together time. I have Marco and I have Cliff. So I need to figure out what this is. First off, together, we know that it's 5 hours. That part was given. But in order to solve, I can only have one unknown variable. I can't both have M and C unknown. That wouldn't allow me to solve. I can only have one unknown variable. So I need to write one of these in terms of the other. And so I come up here and I really think about this statement. Marco can build a laptop twice as fast as Cliff. So Marco is the quicker one. So if Marco, maybe it takes him 2 hours, that means it would take Cliff 4 hours. If it took Marco 8 hours, that means it would take Cliff 16 hours. So see this pattern that whatever amount of time it takes Marco, it takes Cliff twice that. So I take whatever number I have here, so I had 8, I timesed it by 2 to get the 16. So that means Marco is just Marco, but then I take whatever Marco did and I multiplied it by 2 to get Cliff. So that's actually how I'm going to do this, is I'm going to put Cliff in terms of Marco. This is also really useful to set it up this way because I'm solving for Marco himself, so this is the variable that I'm going to be solving for. Now I can go ahead and put this into my form. We know that together time goes on top, and then the individuals go on bottom, so it's M and 2M. Our next step is to go ahead and add. We know that in order to add, they have to have a common denominator. We can't add now, so we get 15 over 2M equals 1. Cross multiply gives me 15 equals 2M. Now we're ready to solve. Divide both sides by 2, and we get M equals 7.5 hours. So it takes Marco 7.5 hours to build a laptop. You could be super fancy if the question didn't ask for it, but if you wanted to, you could say that then it takes Cliff 15 hours. That's a long amount of time to make a laptop. So we could double that time. That's what I did here. So it took Marco 7.5, so I doubled that to get the 15 here. And that is how you can solve one. So sometimes you do have to think critically and figure out how do the people relate to each other and how can you deal with that in your variables. So once again, this is a work rate problem. You might see this formula different, but this is the way that I do the formula, and so this is the way you'll always see me solve them.